Hello everyone. What we're going to do in this video here is we're going to find the terminal point on the unit circle. So what that means is if I'm going to tell you a certain distance we've traveled around the circle and we want to find the x and y coordinates. Okay, so the first thing we need to do is something that the book uses, something that's called the reference number. So let's write that down. So what is a reference number? So the reference number, let's say associated with a distance, let's say t, traveled around the unit circle, denoted by t bar, is the shortest distance to the x-axis. Traveling along the circle, unit circle. Okay. So let's give this a shot. So let's do a couple examples here. I'm going to go ahead and erase this. So we'll do a couple different examples. So let's draw one picture here. Let's say we've traveled a distance t along the unit circle. So here's a distance t. Now what this t bar would be, what we call the reference number, it's the shortest distance to the x-axis. So the shortest way to get to the x-axis would be traveling from here to here. So this distance right here, this is what we denote as t bar. Okay, let's draw another picture. Here's another example. Let's say we've traveled a distance, I don't know, how about this is the distance t that we've traveled along the unit circle. So again, I should say that the distance here is 1 since it's the unit circle. What t bar would be with the shortest distance to the x-axis, so that would be this distance right here. This is what we would call t bar. Okay. So another example. We'll do two more. Let's say we travel a distance, I don't know, how about this far? Let's say this is the distance t. And t bar would be the shortest distance to the x-axis. The shortest way to get there would be going along this way. So the distance from here to here, this is what we would call t bar. Let's do one more. T and t bar will be the same if we're in the first quadrant. So here's the unit circle. Let's say I travel a distance t along the unit circle, and the shortest distance to the x-axis would be here, so this would be t bar. So in this case, t and t bar would be the same. Okay, so now let's go through an exercise of finding the terminal point on the unit circle if I've traveled a distance t around the circle. So there's certain steps that you'll follow. So using the reference number to find the terminal point. On the unit circle. And what I'm meaning, I guess if I haven't explained this already, what a terminal point means is when I've traveled a certain distance, the terminal point is the x and y coordinates of that point in the unit circle. So the steps you'll follow is when they're giving you a distance t to travel around the unit circle, what you'll do here is you'll first find what t bar is, the reference number. 2, you'll find the point x and y associated with t bar in the first quadrant. And then 3, we'll adjust the sign in part, 2, depending on which quadrant t is in, where t is the distance we've traveled along the circle. Okay, so let's go ahead and do an example. Okay, so we'll do a couple of them. So our first example here, let's say I'm traveling a distance t of 7 pi over 6 along the unit circle. So the first thing I'm going to do is I'm going to draw the unit circle and I'm going to figure out where we're located. So I'm always just going to remember in my head that the unit circle is built of increments of pi over 6 and increments of pi over 4. So if I draw the unit circle, circle of radius 1, we're going to move 7 units of pi over 6 around the unit circle. So we'll go ahead and count. So here's 1, 2, 3, 4, 5, 6, 7. So this distance here, I've walked a distance of t of 7 pi over 6. This would be radians. Remember, radians is the number of radiuses we've walked along. We've walked 7 pi over 6 radiuses around the circle. In this case, it's a radius of 1. So this is where we are. So here we are at a t value of 7 pi over 6. So what we'll do now is we'll think about what t bar would need to be here. So this would be step 1. So t bar here is going to be the distance, we'll do it in blue, the distance from here to here. So the distance from here to here should be really just 1 increment of pi over 6 if we're starting here. So t bar here will be pi over 6. So we first figure out that t bar is pi over 6. Okay, now step 2, what we're going to do is we're going to figure out the x and y coordinates if we traveled a distance of pi over 6 along the unit circle in the quadrant 1. So if I go from here to here, this is a distance of pi over 6, and we'll want to think about what the x and y coordinates are right here. So if we use our hand trick, we put down our pi over 6 finger, the x coordinate will be root 3 over 2, and the y coordinate will be root 1 over 2, or 1/2. So this will be root 3 over 2 and 1/2. So this is part 2, root 3 over 2 and 1/2. And for step 3 here, what we want to do is we really just want to adjust the sign of, these coordinates because t is now in the third quadrant. I actually draw a nice little triangle right here. I hope you see that these two triangles here are the same. We're just in a different location here. So in this case here, if I'm in the third quadrant, the x coordinate is negative and the y coordinate is positive, so we'll adjust the sign here. So if I've traveled a distance of 7 pi over 6 around the unit circle, the x coordinate will now be negative, so it'll be negative root 3 over 2. Oh, sorry, the y coordinate is also negative here. And the y coordinate will be negative 1/2. So that's the answer. Let's do another one. Okay. So let's say t is negative 4 pi over 3. So when I'm traveling a negative distance, what that means is I'm not traveling counterclockwise, I'm actually traveling clockwise around the circle. So if it's a negative distance, I'm traveling this way along the circle. If it's a positive t value, I'm traveling this way along the circle. So let's first try to figure out where we are on the unit circle. So for me, I remember that the unit circle is built of increments of pi over 4 and pi over 6. So I'm going to adjust this by doing the best trick in the math book. I'm going to multiply by 2 over 2. So we have that t will be negative 8 pi over 6. So I know I'm going to move 8 increments of pi over 6 clockwise around the unit circle starting at 1, 0. So where are we? Okay. So starting here, we'll move 8 increments of pi over 6 clockwise. So here's 1, 2, 3, 4, 5, 6, 7, 8. So I've walked a distance around the circle of t, which is negative 8 pi over 6. So now our job here is to figure out what t bar is. So t bar is the shortest distance from the x-axis, so that's from here to here. So here we have that t bar. In this case here, notice it's 2 increments of pi over 6 if I'm counting from here. So this will be 2 increments of pi over 6. So 2 pi's over 6, or pi over 3. So to answer our first question here, we have that t bar will be equal to pi over 3. Okay, so for part 2, what I want to do is I want to think about the x and y coordinates if I travel pi over 3 units around the unit circle in the first quadrant. So here's 1 increment of pi over 6, 2 increments of pi over 6, which is pi over 3. So here, this is when we're at pi over 3 units around the unit circle. Let's figure out what the x and y coordinates are if we use our hand trick. We'll put down our pi over 3 finger, so the x coordinate will be root 1 over 2, or 1/2. And the y coordinate will be root 3 over 2. And for part 3, what we want to do is we now just want to adjust this depending on what quadrant you're in. Well, since t is in quadrant 2, this is where our x coordinate is negative and our y coordinate is positive, so we'll adjust the sign. So our x coordinate is negative, so negative 1/2, and our y coordinate is positive, root 3 over 2. And this is the answer. So again, if we look at kind of the triangles that are being built here, if I think about this triangle right here and this triangle right here, these triangles are the same, they've just been mirrored over the y-axis. Okay. Let's do another example. Let's say that t is 5 pi over 4. We want to find the terminal point if we've traveled 5 pi over 4 units around the unit circle. So the first thing we're going to do is we're going to draw our unit circle and we're going to figure out where we are. So now we've moved 4 increments, or 5 increments of pi over 4. So we'll count. So here's 1, 2, 3, 4, 5. So this is where we are on the unit circle. So this distance I've traveled along the circle, t, is 5 pi over 4. So let's think about what our t bar would be here. So it's the shortest distance to the x-axis. So that'll be this distance right here. So here I've just really moved 1 increment of pi over 4 if we're starting here. So our t bar will be pi over 4. So that's our first step. We have that t bar is pi over 4. So So for step 2, we want to think about traveling a distance of t bar around the circle starting here, where we're thinking about the x and y coordinates in the first quadrant if we travel pi over 4 units. So that means we would be right here. So from here to here, this is a distance of pi over 4. So the xy coordinates here, if I put down my pi over 4 finger, the x coordinate is root 2 over 2, and the y coordinate is root 2 over 2. So here we'll go root 2 over 2 and root 2 over 2. So that is step 2. Root 2 over 2 and root 2 over 2. So now we'll just want to adjust the sign of this. For the quadrant we're in, since we're in quadrant 3, we have that the x-coordinate is negative and the y-coordinate is negative. So we'll have a negative root 2 over 2 and a negative root 2 over 2. And this is the final answer. And again, if we think about the triangle that's created right here, it'll be the same triangle that's created right here. It's just the x and y coordinate have been reflected. Okay. Let's do one more example. What if we have a really large value of t? Let's say t is 15 pi over 4. I want to know the terminal points here. So notice that this number is bigger than 2 pi. So I've traveled along the unit circle more than one time. So what I like to do here is just kind of adjust this number. Get the computer turned off. Okay. So what I'm going to do here is I'm going to think about how many times 4 goes into 15. So 4 can go into 15, let's see, 3 times? So 3 times 4 is 12. So how about I break this up as 12 pi plus 3 pi. I'll write that as all over 4. So if I distribute the 4 here, 4, so I'll have 12 pi over 4 plus a 3 pi over 4. So this is going to be reduced to 3 pi plus 3 pi over 4. If you would like, this is 2 pi plus 3 pi over 4. So this means I've traveled along the unit circle 1.5 times, and then I need to travel an extra distance of 3 pi over 4. So if I draw our picture here, we've gone around the circle 1 whole time plus another half. So going around once and then another half. So I'm right here. Now I'm going to count 3 increments of pi over 4. So 1, 2, 3. So if I was to draw t, I would have gone around once and a half and an extra 3 pi over 4. So this would be t, which is equal to 15 pi over 4. So let's think about what t bar is going to be. It's going to be the shortest distance to the x-axis. So t bar will be this distance right here. So t bar, this is going to be 1 increment of pi over 4, so pi over 4. So for our first step, we found what t bar is. T bar is pi over 4. Okay. So we'll think about what the x and y coordinates of pi over 4 are in the first quadrant. So here's a distance of pi over 4. And if we use our hand trick, the x and y coordinates at pi over 4 are going to be root 2 over 2 and root 2 over 2. So here we have root 2 over 2 and root 2 over 2. So that's step 2. For part 3, what I want to know is I just need to adjust the sign of this for this quadrant. So since we're in quadrant 4, here we have that the x-coordinate is positive and the y-coordinate is negative. So we'll have a root 2 over 2 and a negative root 2 over 2, which is the answer. Okay. I hope you found this helpful. I'll see you in the next video. Take care.